Close your eyes and let yourself go somewhere ancient, somewhere older than memory, somewhere the trees are so tall they seem to hold the sky in place, where the air is heavy with moisture and the smell of rich, dark soil, and where every surface, every stone, every root, every gently curving branch is layered in a velvet deep green that has no name in any human language. Breathe in slowly. Let your shoulders fall away from your ears. Let your jaw unclench. Let your hands rest, soft and open, wherever they are right now. You are in the forest. Not just any forest. This is one of the oldest, most layered ecosystems on the surface of our planet. You are deep in the heart of equatorial Africa, somewhere in the ancient belt of rainforest that stretches from the west coast of Senegal and reaches all the way east to the banks of Lake Tanganyika. The air here is warm, not uncomfortably warm, but the kind of warm that wraps around you like a gentle hand, the kind of warm that makes your muscles soften and your breathing slow. The humidity lifts every scent from every surface. The earth beneath you smells like something alive, because it is. Every handful of this forest soil contains more living organisms than there are people on Earth. Listen, if you can, to the sounds of this place. Far off, perhaps half a mile through the trees, there is water. A small river, shallow and quick, passing over smooth stones. You can hear it faintly, a low and constant whisper threading through the deeper silence of the forest. Closer by, the canopy overhead sways in a breath of wind. You cannot feel the wind down here at the forest floor. Down here, it is still and dim and wonderfully cool in the shade of those enormous trees. But you can see the movement of the leaves above, a slow and rhythmic shimmer of green and gold where the sunlight breaks through, and you can hear the soft collective sigh of 10,000 leaves stirring all at once. Birds are calling from somewhere high above you. Not the sharp, insistent calls of alarm. These are the long, rolling songs of birds at rest, birds that have found their perches for the afternoon. The sound floats down through the layers of the canopy like something liquid, soft and unhurried. A small insect hums near your ear, traces a lazy arc in the warm air, and disappears again into the green. Somewhere to your left, a drop of water falls from a high leaf onto a lower one, then onto another, working its way down through the canopy in a series of tiny, patient taps. You are perfectly safe here. You're a guest in this forest, and the forest knows how to hold its guests. Take another slow breath in. Feel the air fill your lungs. It is rich here, full of oxygen generated by more leaves than you could count in 1,000 lifetimes. And as you breathe out, let yourself settle just a little more deeply into stillness. Because something is going to happen in this forest tonight. Something that happens every day in these ancient trees. Something that has been happening since long before any human being walked out of Africa and into the rest of the world. Something that, in ways you might not expect, is intimately connected to who you are and how you feel and how you think and how you love. There is a rustling high above. You look up, and through the layered green of the canopy, at the junction of two enormous branches as thick as a person's torso, rough-barked and draped in moss, you see a shape, dark and still and deliberate, a shape that is reaching one long arm toward a nearby branch, fingers wrapping around the wood with slow, unhurried certainty. A shape that is looking out across the forest with large, dark eyes that seem to hold a kind of quiet intelligence, a kind of knowing that stops your thoughts in their tracks. You are looking at a chimpanzee, and for a long suspended moment, the chimpanzee is looking back at you. There is nothing threatening in this gaze, nothing aggressive or uncertain. there is only a deep and ancient recognition. The sense of two creatures who, despite the miles between them, despite the vast difference in their daily lives, shares something so fundamental, so woven into the very fabric of what they are, that neither one can fully explain it. The chimpanzee tilts its head slightly to one side, blinks once, and then turns its attention back to something in the branches farther along, something that matters in the private language of the forest. This is where your journey begins tonight. Here, in this ancient and generous forest. Here, in the presence of the being who is, of all the living things on this earth, the closest to a mirror of yourself. Here, where science and wonder and the slow, patient breathing of the natural world come together in something that is not quite like anything else. For the next 2 hours, you are going to rest here. You are going to listen. And as you drift between wakefulness and sleep, the story of the chimpanzee, their extraordinary bodies, their remarkable minds, the deep and intricate weave of their societies, and the long shared thread that connects them to us, is going to unfold around you like the forest itself. There is nothing you need to do, nowhere you need to be. Only here, only now, only the sound of the river, the shimmer of the leaves, and the quiet, intelligent eyes of our closest cousin, watching from the canopy above. Long before there were forests of glass and steel, long before there were roads or ships or the measured ticking of clocks, this world was a vastly different place. And somewhere in that older world, approximately 6 to 7 million years ago, in a landscape of open woodlands and humid forests that no human eye has ever seen, two paths diverged. Until that moment, the creatures who walked one path and those who would eventually walk the other had been the same. The same eyes, the same hands, the same general shape of a life spent in and among trees. And then, slowly, over thousands and thousands of generations, in the patient, unhurried way that nature alone can manage, those two paths began to lead in different directions. One path would eventually lead, after millions of years and countless small changes, to a creature that would stand upright in the afternoon sun, look up at the stars, and begin to wonder what they were. The other path led to the chimpanzee. And here is the extraordinary thing. Here is the fact that stops scientists and philosophers and ordinary people alike in their tracks every time they really let themselves sit with it. Those two paths were not separated by very much at all. Geneticists, the scientists who study the chemical code that blueprints every living thing, have mapped the entire genome of the chimpanzee. They have compared it letter by letter to the human genome, and what they found was this: chimpanzees and humans share more than 98% of their DNA. More than 98% of all the chemical instructions needed to build a chimpanzee, to grow its body, wire its brain, shape its hands, govern its emotions. More than 98 out of every 100 are identical to the instructions needed to build a human being. To put that in some perspective, the genetic distance between a human and a chimpanzee is smaller than the genetic distance between a chimpanzee and a gorilla. Two creatures who appear, to the casual eye, to be close cousins are actually more distantly related to each other than either is to us. We are the chimpanzee's closest living relative, and the chimpanzee is ours. Let that rest in your mind for a moment, gently, the way a leaf rests on still water. The soft breathing of the chimp you can see in the branches above you, the rise and fall of that dark-furred chest, the quiet blink of those dark eyes, is built on almost exactly the same molecular foundation as your own breathing, your own blinking, your own quiet presence here in this forest tonight. Something deep in both of you recognizes the other. Something older than language, older than any memory you carry, knows this bond. The common ancestor of both humans and chimpanzees was likely a creature something like Sahelanthropus chidensis, whose fossil remains were discovered in the country of Chad in the early 2000s. Dating back approximately 7 million years, this small-brained, partially upright creature lived near the edge of a receding lake in a landscape where forest met open grassland. It was neither fully human nor full ape. It was the beginning of a branching, a gentle divergence that the universe was taking, a new question it was asking of life. From that point, two lineages developed along their separate paths. The lineage that would become chimpanzees stayed close to the forests, refining their tree climbing abilities, deepening their social complexity, sharpening the tools of a mind suited for a life among branches. The lineage that would become human ventured increasingly into open ground, lengthening its legs, stiffening its feet, freeing its hands for something other than locomotion. Now, there's actually not just one species of chimpanzee, but two. The first is the common chimpanzee, known scientifically as Pan troglodytes, the chimp most people picture when they hear the word, with its dark fur, its distinctive face, its wide range across the forests of Central and Western Africa. The second species is the bonobo, Pan paniscus, a slightly more slender, more graceful cousin that lives south of the Congo River in the dense forests of what is now the Democratic Republic of Congo. These two species, the common chimp and the bonobo, are as closely related to each other as we might expect from cousins, having parted ways only 1 to 2 million years ago, well after both of their lineages had already separated from ours. So when you look at the chimp in the branches above, you are looking at something that sits at the very heart of a family triangle. You, the chimpanzee, the bonobo. 3 species all descended from the same ancient ancestor, all carrying in their bodies and their brains the echoes of a shared beginning.
Breathe slowly. You are connected to this forest more deeply than you might ever have imagined. The chimpanzee above you shifts its weight, moving one foot from one branch to another with a casualness that speaks of a lifetime spent in trees. A lifetime of knowing exactly where each foot will land, of trusting the wood beneath and the air around and the body that has been shaped over millions of years precisely for this. Its hand releases one branch and finds another a little farther along, and for a moment it hangs there in the warm air, suspended between 2 trees, utterly at home. There are currently between 170,000 and 300,000 chimpanzees living wild in Africa. That number sounds large, but it represents a fraction of what once existed, and it is a number that is, year by year, diminishing. These animals are classified as endangered by the International Union for Conservation of Nature, the body of scientists and conservationists who track the health of species around the world. We will come back to their story and to the many people working to protect them a little later in our journey tonight. For now, simply know that each one of those 170,000 individuals carries within its cells more than 98% of your own biological inheritance. Each one is, in a sense, a distant relative, a cousin many thousands of generations removed, but a cousin nonetheless. The forest is very quiet now. A low wind passes through the upper canopy, and the leaves above you shimmer and sigh. The chimp in the branches settles against the fork of 2 great limbs, its body relaxed, its eyes half closed. Its breathing is slow and steady. And yours can be too. Let your body rest a little more with each breath out. Feel the warmth of the air around you. Let the sounds of the forest, the water, the birds, the soft percussion of leaves carry you gently forward into the story.
To understand a chimpanzee, you must first understand what it feels like to live in 3 dimensions. Most of us spend our lives navigating a world that is essentially flat. We walk on floors, on paths, on roads, surfaces that hold us reliably from below. We move forward and back, left and right, but very rarely up and down in any meaningful way. Our world is a 2-dimensional world dressed in 3-dimensional clothing. The world of a chimpanzee is profoundly different. Their world is vertical. Their world is a cathedral of wood and leaves and living air, a 3-dimensional labyrinth of branches and pathways that extends 30, 40, sometimes 50 meters above the forest floor. Their world asks of them a constant, real-time negotiation with gravity, a continuous calculation of distance, weight, momentum, and grip. And their bodies have been shaped over millions of years of evolution to meet exactly that challenge. Begin with the hands. Stretch out your own hand for a moment if you like, or simply imagine it. Notice the shape of your fingers, relatively straight, moderately long, converging gently toward your palm. When you grip a cylindrical object, your fingers form something like a square, pressure concentrated at certain points, slightly uneven in its distribution. Your thumb can reach around and meet your fingers, giving you a functional grip, but the geometry of your hand was designed with other priorities in mind. It was designed for fine manipulation, for threading a needle, for turning a page, for the intricate small movements of tool use and writing. A chimpanzee's fingers are different in a way that changes everything. They are longer than yours proportionally, and they are curved, not a straight cylinder, but a gentle arc, so that when a chimp closes its hand around a branch, those curved fingers wrap the wood in something much closer to a true circle. The pressure is distributed more evenly around the circumference. The grip is more secure. A chimpanzee can clasp a branch significantly thicker than any human hand could manage, and it can do so with a degree of confidence and security that has no human equivalent. The average adult man, using a proper grip measurement device, can squeeze with a force of approximately 73 pounds, that is, roughly 33 kilograms. Women typically average around 44 pounds, or about 20 kilograms. These are healthy, functional figures. They allow us to carry grocery bags and open jars and shake hands firmly. But various measurements and studies have consistently found that the grip strength of an adult chimpanzee dwarfs these figures by an enormous margin. While the precise numbers vary across studies, and some early estimates were likely overstated, the general consensus among researchers is that chimpanzee grip strength is several times greater than human grip strength. Not twice, not 3 times, several times. The reason for this is not mysterious. Chimpanzees spend a significant portion of their lives hanging, swinging, climbing, and clinging. A young chimpanzee will spend well over half an hour a day simply hanging by its arms. Their upper body musculature, the muscles of the shoulders, arms, back, and hands, has been under intense evolutionary pressure to maximize strength and endurance, because the cost of failure in a treetop is not a bruised ego, but a fatal fall. Now come down from the hands to the feet. Look at your own foot. Your big toe is aligned in parallel with your other 4 toes, pointing forward. Beneath your foot, there is a gentle upward curve, the longitudinal arch, that stiffens the foot and acts as a spring, storing and releasing elastic energy with each step you take. The heel of your foot, the calcaneus, is enlarged and robust. It is built to strike the ground, to absorb the impact of walking, to be the first point of contact in the long, efficient stride that carries humans across distances that no other great ape can match. Your foot, in short, is a walking machine. It is exquisitely engineered for the repetitive, forward momentum locomotion of a biped on flat ground. The foot of a chimpanzee is something entirely different. The big toe of a chimpanzee stands apart from the other 4, much as a human thumb stands apart from the fingers. It is opposable. This means a chimp's foot can grasp things, can wrap around branches, can grip a vertical surface with much the same confidence that your hand grips a handrail.
The chimp's foot is, in a very real sense, a second pair of hands. This arrangement makes the foot far less efficient for walking on flat ground. There is less of a stiffening arch, and the gait is less mechanically efficient, but it makes it extraordinarily capable in the complex, multi-directional grip demands of arboreal life.
So, a chimpanzee, when it moves through the treetops, is gripping with all 4 limbs simultaneously. 4 hands, essentially, each one capable of a secure hold on wood of varying thicknesses and orientations. The chimp does not clutch and scramble through the canopy. It moves through it with a fluid, almost relaxed confidence, choosing its route with quiet deliberation. When a chimpanzee descends to the forest floor, as they often do, it adopts a mode of movement called knuckle walking. This is one of the more distinctive and memorable features of great ape locomotion. Rather than placing the palm of the hand flat on the ground, the knuckle walker curls the fingers inward and places the weight on the backs of the middle finger joints, the knuckles. It is a gait that looks, from a distance, both powerful and unhurried. The dark-furred body moving with a rolling, deliberate rhythm that speaks of great strength held comfortably in reserve. Knuckle walking is shared among primates only by the African great apes, chimpanzees, bonobos, and gorillas. And the reason for this shared adaptation goes back to those long, curved, grasping fingers. Fingers shaped for gripping branches are not ideally shaped for flat-palmed ground contact. They would bend backward uncomfortably, strain the joints, and be vulnerable to damage. By walking on the knuckles, the ape protects those precious grasping fingers while still achieving efficient 4-limbed locomotion on the ground. It is a remarkably elegant solution, one that protects the body's most valuable tool while still allowing ground travel. Knuckle walking also has the advantage of freeing the hands, even while walking, to carry things. A chimpanzee moving across the ground on 3 limbs while cradling a piece of fruit or a handful of leaves in the 4th is not an unusual sight. The locomotor pattern is flexible enough to accommodate this, making it a practical everyday mode of transportation. Adult male chimpanzees weigh roughly 40 to 60 kilograms, that is, 88 to 130 pounds. Females are somewhat smaller, typically ranging from about 32 to 47 kilograms. They stand, when upright, somewhere between about 3 and 5.5 feet tall. Their arms are proportionately longer than ours, their torsos more compact, their legs somewhat shorter in relation to total body size. From the outside, a chimpanzee's body gives an immediate impression of compact, coiled strength. Not the lean, long-limbed strength of a runner, but the dense, immediate strength of a climber, of an animal that routinely hoists its own body weight up vertical surfaces and swings itself through the air between trees.
Their coat is coarse and dark, black or very dark brown in most individuals, softening slightly to paler tones on the face and ears, which become darker with age. Young chimps are born with a distinctive pale face that gradually deepens in color as the animal matures, providing a visible cue to age and developmental status within the group. A chimpanzee's face is, in many ways, the most striking aspect of its appearance. The brow ridge protrudes slightly above deep-set dark eyes that are surprisingly expressive, capable of a range of subtle movements that convey attention, curiosity, unease, and something that looks, in certain moments, very much like recognition. The ears are relatively large and set wide apart. The lips are mobile and flexible, used extensively in facial communication. The jaw is powerful, and behind those mobile lips are teeth, 32 of them, the same number as in an adult human mouth, but arranged somewhat differently. And in adult males, the canine teeth are dramatically enlarged, long, sharp, and unmistakable. But we will speak more about the social and emotional world of that face a little later when we turn to the extraordinary communication between these animals. For now, let your mind's eye simply rest on the chimpanzee in the branches above. The long arms, the grasping hands and feet, the dark fur, the attentive face. A body built for a world of wood and air. A body shaped by millions of years of life in the high canopy of ancient African forests.
and not so very different at its deepest level from the body you inhabit right now.
There is a quality to the strength of a chimpanzee that is different from merely being strong. A human athlete, a weightlifter, a gymnast, a rock climber at the peak of their training can achieve impressive feats of physical power. But the strength of a trained human is, in some ways, a performance. It is cultivated, maintained, deliberately developed through years of effort. It has to be worked for, sustained, and it diminishes over time if the training stops. The strength of a chimpanzee is simply what the chimpanzee is. It does not need to go to a gym. It does not need a training regimen. The strength is built into every fiber of its body, expressed in every movement, every climb, every reach across the open air. It is the strength of an animal for whom climbing is not exercise, but life itself. Not something done for fitness, but something done for food, for safety, for the daily fabric of existence. In 2017, researchers took a careful and methodical look at what precisely makes chimpanzee muscles so much more powerful than human muscle. They found that the difference comes down to a matter of composition. In any muscle, there are two broad categories of fiber: slow-twitch fibers, which contract more slowly but are very resistant to fatigue and are used for sustained endurance activities, and fast-twitch fibers, which contract quickly, generate explosive bursts of power, but tire more rapidly. Think of slow-twitch fibers as the engine of a long-distance runner and fast-twitch fibers as the engine of a sprinter. In human muscle tissue, these fibers are present in roughly a 60-40 ratio. That is, about 60% slow twitch and 40% fast twitch. This is a balance that reflects our evolutionary heritage as long-distance walkers and runners. We are built for endurance, for sustained effort over time and distance. A Homo sapiens at full physical capability is not explosive in the way of a large cat, but can cover extraordinary ground over hours and days. Chimpanzee muscle, by contrast, is composed of approximately 33% slow-twitch fibers and 67% fast-twitch fibers. More than 2/3 of a chimpanzee's muscle mass is oriented toward explosive, immediate, powerful contraction. And beyond the fiber-type composition, the actual architecture of each fiber, the way the muscle is structured at the cellular level, generates more force and power per unit of weight. The same 2017 study concluded that pound for pound, chimpanzee muscle produces approximately 1.5 times the force and power of equivalent human muscle.
1.5 times. In a body that is already denser, more compact, more heavily muscled in the upper body than a human body of similar size. The result is an animal of genuinely remarkable physical capability. One that can swing its full body weight through the canopy with apparent ease, hang by one arm for extended periods, and navigate the complex three-dimensional world of the treetops as naturally as you navigate a footpath. Complementing this muscular power are bones that are, on average, denser than human bones, and tendons that are proportionally thicker and stronger. Bones and tendons are the structural partners of muscle. Without strong enough bones to anchor to and strong enough tendons to transmit force through, even the most powerful muscle cannot be used effectively. In the chimpanzee, the entire musculoskeletal system has been tuned over millions of years into a coherent and remarkably powerful whole. And then, of course, there are those teeth. The canine teeth of an adult male chimpanzee are, by any objective measure, formidable. In most primates, including humans, the canines have been reduced over evolutionary time. We have canines, technically, but they are barely distinguishable from our other front teeth. In the chimpanzee, however, the male canines have been retained and in some ways enhanced. Long, sharp, and anchored in deep, strong sockets, they serve primarily as social instruments, tools of display and threat rather than hunting weapons. When a male chimpanzee wants to signal dominance, one of his most powerful visual statements is simply to reveal those teeth,
to open the mouth in a controlled, deliberate way that shows the full, unmistakable length of the canines to whoever is watching. But we have perhaps lingered long enough on the physical capabilities of these animals, because the body of a chimpanzee, as extraordinary as it is really only the vessel for something far more interesting, the mind that lives inside it. Rest comfortably. Let your breathing stay slow and steady. The forest around you is still warm, still gently lit by the softening afternoon light filtering through the high canopy. The chimp in the branches has been joined now by a companion, another dark shape, approaching along the same bough, moving with that same unhurried confidence. They settle near each other, close enough to touch, and for a moment they are simply still. Two shapes in the green light, breathing quietly. Watch them. There is a quality of presence to two chimpanzees at rest together that is difficult to describe and easy to feel. It is a sense of companionship that seems to predate language, to predate any specific cultural form of friendship. It is simply warmth. The warmth of two beings who know each other, who trust each other, who find in each other's proximity something that neither has alone. That is what we are going to explore next. Imagine for a moment that the world you live in has no floors. That instead of walking on flat, horizontal surfaces, you spend your days in a world of curves and angles, where your floor is a branch that might be anywhere from 2 to 40 meters above the actual ground, where the direction of travel is as often vertical as horizontal, where the spaces between your footholds are measured not in inches but in body lengths, and where your whole sense of direction and safety depends not on what is beneath your feet, but on what your hands are touching. This is the world the chimpanzee inhabits most naturally. The canopy of an African tropical rainforest is not a single layer, but a series of them. At the very top, the emergent layer, the tallest trees rising above everything else, their crowns spread wide in the full sun. Just below, the continuous canopy itself, a dense, tangled ceiling of interlocked branches and leaves roughly 20 to 40 meters above the forest floor, through which most of the sunlight that reaches this environment must pass. Below that, the understory, a darker, more sheltered world of smaller trees and shrubs adapted to the filtered light that makes its way down through the two layers above. And at the very bottom, the forest floor itself, dim and rich and damp, where fallen leaves slowly become the soil of the next generation. A chimpanzee uses all of these layers. It may sleep in a nest constructed in the upper canopy. It may feed on fruits found in the canopy itself or in the understory. It may walk on the forest floor when traveling longer distances or crossing open ground. It is a creature of the vertical, fluent in all these layers, moving between them with an ease and naturalness that makes the whole forest into a single integrated home. Before we go further into the canopy, pause for a moment and feel the scale of this environment. You are standing at the base of a tree whose trunk is wider than you could reach around with both arms extended. Its bark is rough beneath your fingers if you were to touch it, furrowed and dark, layered with moss and lichen and the tracks of beetles. The roots sprawl out from the base in enormous sinuous curves, some of them above ground for meters before diving back into the earth, creating small chambers and hollows where other plants root and small animals shelter. Looking straight up, the trunk rises and rises and rises until it resolves into branches that are themselves the size of large trees, and those branches hold smaller branches, and those hold smaller ones still, until the uppermost reaches of the crown dissolve into the open sky in a shimmer of 10,000 small leaves. Between this tree and the next one, 15, 20, 30 meters away, the canopy bridges the gap. The upper branches of neighboring trees interlock, creating a continuous pathway of connected wood that a chimpanzee can follow for miles without ever descending to the forest floor. From below, this canopy looks impenetrable, a solid ceiling of green.
But from within it, as the chimps experience it, it is a complex three-dimensional road system full of branches of varying thickness and reliability, crossing angles, gaps, and connective routes that reward knowledge and punish overconfidence. The particular style of movement that chimpanzees use in the trees, swinging from branch to branch using their arms, has a specific name: brachiation. It is the defining locomotor technique of the gibbons and siamangs of Asia, who do it almost exclusively, and it is used by the great apes, including chimps, as one tool among several for navigating the canopy. When brachiation is in full swing, when a chimp is moving fast through the treetops, reaching forward with one arm and releasing with the other, body pendulating between grips in a smooth, flowing arc, it is one of the most breathtaking movements in the animal kingdom. Watch a gibbon or a chimpanzee brachiating at speed, and you will understand immediately and viscerally why the human response is often to hold its breath. There is something about the combination of height, speed, and apparently effortless control that is simultaneously thrilling and deeply calming. The visual equivalent of watching water flow over stones or watching a bird bank into a turn on a thermal. The arc of each swing is a small act of physics, controlled by the length of the arm and the distance between holds, shaped by the momentum carried from the previous swing, maintained by the extraordinary grip of those curved, muscular fingers. The animal does not reach blindly. It chooses its next grip from among the available branches in a fraction of a second, weighing distance and thickness and angle in an instantaneous calculation that our own slower, more deliberate minds would struggle to match.
This speed of spatial processing is, as we will discover shortly, one of the most remarkable things about the chimpanzee's mind. The ability to read a complex three-dimensional scene in an instant, to memorize it, to act on it, to move through it with perfect confidence. The forest has shaped not just the chimpanzee's body, but its mind as well, honing certain cognitive capacities to a degree that, in some respects, goes beyond what human minds can do. But the canopy is not only a highway, it is also a pantry. Many of the foods that chimpanzees prefer, ripe fruits, certain leaves, figs, flowers, and honey, are found primarily in the upper layers of the forest. The ability to reach these resources, to navigate the three-dimensional maze of branches that separates one fruiting tree from another, is what makes the chimp's physical and cognitive toolkit so valuable. A chimpanzee with good spatial memory can navigate a forest that might cover several square kilometers, remembering where the fig trees are, when they fruit, which routes connect which resources, carrying in its mind a detailed, constantly updated map of its territory. This map is not static. The forest changes. Trees fruit at different times. Water sources shrink and expand with the seasons. Other chimpanzee groups move through neighboring territories. The map that a chimpanzee carries in its mind is a living document, updated, revised, and referenced constantly as the animal moves through its world. And a chimpanzee's world is not just physical, it is deeply, irreducibly social. Every chimpanzee that you might encounter in these ancient forests is embedded in a web of relationships so complex, so layered, so rich with history and nuance that it would take a very long time to even begin to describe it fully. Chimpanzees live in what biologists call a fission-fusion society. This is a deceptively simple phrase for a very sophisticated way of organizing social life. The basic idea is this: chimpanzees belong to a large community, which may number anywhere from around 20 individuals to more than 150. This large community is the ultimate social unit. Every chimpanzee in it knows every other chimpanzee. They share a common territory, recognize common allies, and together constitute a kind of social nation. But within that nation, the animals do not all move and feed and sleep together all the time. Instead, the large community constantly subdivides into smaller, more fluid parties, groups of 2, 5, 10, 20 individuals who happen to be traveling and feeding together on a given day. These smaller parties form and dissolve and reform continuously, depending on where the food is, who feels like traveling with whom, and a dozen other factors that are only partially understood, even by the scientists who have spent decades studying them. Today, a female and her young offspring might travel with 2 young adult males and an older matriarch. Tomorrow, those males might have split off to travel with a different group, and the females might be alone or joined by others. The day after, a larger party might come together around an exceptionally productive fruiting tree, bringing together individuals who haven't seen each other for a week. This means that every chimpanzee must maintain active social awareness of a large number of individuals, their relative rankings, their known alliances, their likely whereabouts, their recent history of cooperation or conflict. And it must do this without any of the external social scaffolding that humans rely on. No phones, no calendars, no written records, no institution or law to enforce the norms of the community. Only memory. Only the accumulated experience of a lifetime of interactions held in the mind and drawn on daily. The community as a whole is known in the technical literature as the fusion. The smaller subgroups that form within it are the fissions. These terms come from physics, nuclear fusion and fission, and there is a certain poetry in the borrowing. In the world of atoms, fusion is the coming together of smaller units into a larger whole. Fission is the splitting of the larger whole into smaller parts. In chimpanzee society, both processes happen continuously, simultaneously, creating a fluid and responsive social fabric that can contract or expand as the situation demands. Within the community, there is a clear social hierarchy among the males. At the top sits the alpha male, the individual who, through a combination of physical prowess, strategic alliance building, and sheer personality, has achieved the dominant position in the group. The alpha male has preferential access to resources, food, mating opportunities, resting spots, and other individuals defer to him in direct confrontation. His authority is not merely a matter of size or strength, though those things matter. It is also, crucially, a matter of politics. Because in a chimpanzee community, pure physical dominance is not enough to maintain the alpha position. The alpha must also manage his relationships. He must keep his allies close, because without coalitional support, even the strongest individual can be displaced by a coalition of smaller, weaker animals working together. He must be generous enough with food and grooming to maintain the loyalty of his supporters. He must manage rivalries, mediate conflicts, and navigate a social landscape that is shifting constantly beneath his feet, just as the branches of the forest shift beneath his body. This is not a simple or instinctive task. It requires memory, planning, social intelligence, and something that looks, to an observer, very much like political awareness. Below the alpha, the males form a roughly linear hierarchy, not rigid and subject to constant challenge and revision, but real enough that every individual knows, most of the time, where it stands relative to others. Subordinate males may cooperate with each other to challenge a higher-ranking animal. These coalitions, temporary alliances of 2 or 3 or more individuals working in concert, are the engines of social change in chimpanzee communities, the mechanism by which the hierarchy is disrupted and renegotiated. Females also have their own hierarchy and their own complex network of alliances, though the nature of female social bonds is somewhat different. Female chimpanzees tend to be somewhat more solitary in their daily lives than males, often traveling with their dependent offspring rather than in large mixed parties. But they form real and lasting friendships with other females, often of similar rank, and sometimes with male allies as well.
These female bonds provide protection, support, and companionship in the complex and sometimes unpredictable world of the community. Both male and female young chimpanzees spend their first years in the constant company of their mother, learning the social landscape of the community as they grow. They watch their mother's interactions, absorb the implicit lessons of who defers to who grooms who shares food, and who does not. By the time they reach adolescence, around 10 to 13 years of age, they have already accumulated years of social observation and experience that will shape the rest of their lives. At adolescence, females typically leave their birth community and travel to a neighboring group, where they will spend the rest of their lives. This movement between communities prevents inbreeding and introduces new genetic material into each group. It is a significant and often difficult transition, arriving as a stranger in a community where everyone already knows each other, slowly building new relationships, finding one's place in a social order that was established before you arrived. Males, by contrast, remain in their birth community for life. They grow up among their companions, rise slowly through the hierarchy as they mature, form alliances that may last decades, and defend the territory of the community they were born into until old age. In the forest around you now, the light is beginning to soften. The angle of the sun has changed. You can see it in the way the light falls differently through the canopy, less direct, more golden, the shadows of the branches growing longer and more complex across the green forest floor. The warmth of the afternoon is settling into the gentler warmth of early evening. Somewhere above you, the chimpanzees are beginning to think about where they will sleep tonight. Let your own breathing slow a little more. Let your body be heavy and restful. The story continues. Of all the things that chimpanzees do, all the complex negotiations of social hierarchy, all the intelligent problem solving, all the strategic maneuvering of alliance politics, nothing is more central to their daily social life than grooming. Grooming is the great social glue of chimpanzee society. It is the currency of their relationships, the medium through which trust is built and maintained, the physical expression of connection between individuals who might otherwise have very little means of demonstrating what they mean to each other. What does grooming look like? Imagine two chimpanzees seated close together on a wide branch, the late afternoon light falling in dappled patterns across their dark fur. One has turned its back to the other, or tilted its head, or offered a limb, a posture that is both an invitation and a form of trust, of making oneself vulnerable to another's touch. The second reaches out and begins to part the fur of the first with careful, focused fingers, working slowly through the coat, searching with almost meditative attention for the tiny insects, parasites, flakes of skin, or bits of debris that accumulate there. When something is found, it is examined briefly, then removed, eaten sometimes, since many of the parasites removed during grooming are actually nutritious. But the finding and removing is almost secondary to the quality of attention that accompanies it. The grooming chimpanzee is fully present, fully focused on its partner. The being groomed grows still and relaxed. Its eyes may close, its breathing slows. Its body, which normally carries the constant low-level alertness of a wild animal in an environment with real risks, seems to release into a quality of ease that is rarely achieved in any other context. If you have ever had your hair gently combed or felt someone else's fingers move slowly and attentively through your hair, if you have ever received a massage or felt a friend's hand rest warmly on your back in a moment of comfort, you have felt in your human body something of what chimpanzee grooming feels like from the inside. The science supports this intuition. Studies have found that grooming in primates triggers the release of endorphins, the brain's natural comfort and bonding chemicals. The physical sensation of careful, attentive touch on the skin produces a measurable neurochemical response, reducing stress hormones and producing a gentle, sustained sense of well-being. This is not metaphorical or sentimental, it is pharmacological. Grooming feels good, and feeling good reinforces the social bond between the two individuals who share it. Primatologists use the frequency and duration of grooming between pairs of individuals as a direct measure of relationship quality. Two chimpanzees who groom each other frequently and for long sessions have a close, trusting, mutually supportive relationship. Two who rarely groom are less connected. The social map of a chimpanzee community can be traced, in large part, through its grooming networks. Who grooms whom, how often, for how long, and in what direction. And those grooming networks matter enormously for survival and success. An individual who has invested heavily in grooming relationships has, in effect, been building a network of allies. When that individual needs support in a confrontation, or needs to share food, or needs protection for itself or its offspring, those grooming partners are more likely to provide it. The relationship is, in the deepest sense, reciprocal. I invest care and attention in you, and you invest it in me. And over time, that mutual investment becomes a bond strong enough to shape both our lives. It is worth pausing here to let the quiet beauty of this sink in. In a world without language, without written contracts, without any of the external mechanisms that human societies use to formalize relationships and obligations, chimpanzees have found a way to build and maintain genuine, durable bonds between individuals. They do it through touch, through presence, through the slow, patient attention of fingers moving through fur, through the shared quiet of two bodies at rest together in the branches of an ancient tree. There is a lesson in this, perhaps, for those of us listening in the darkness. A reminder that the oldest and deepest forms of connection are also, in some ways, the simplest. Not words, not promises, not the elaborate architectures of human social life, but just this: presence, attention, touch, and time. The chimpanzees in the branches above you have been grooming for some minutes now. The one being groomed has its eyes half closed, its body completely relaxed, its breathing slow and deep. The one grooming works steadily, carefully, with a focus and a gentleness that is almost meditative. There is no urgency here, no distraction. There is only this: one being caring for another, quietly, in the green light of the forest afternoon. Let that image rest in your mind. Let your own body feel something of that ease. The ease of being cared for, of being known, of resting in the presence of another. Let your breathing slow. For a long time, far too long in retrospect, scientists assumed that the social relationships of male animals were purely instrumental. Males competed for resources, for rank, for mates. Any cooperation between males was explained as temporary convenience, two individuals working together only until their interests diverged, with no real bond underlying the alliance. What the long-term study of chimpanzees has revealed about male friendship is something far more interesting, and, in certain ways, more moving. Male chimpanzees form genuine, lasting friendships. A 2009 study that followed male chimpanzees in the wild over years of observation found that male pairs, called dyads, maintained consistent, close social relationships for remarkable lengths of time. Half of all the male friendship pairs observed in the study had been close companions for at least 5 years. Some had maintained their bond for close to a decade. These were not alliances of convenience that dissolved when the immediate need passed. They were persistent, mutual, active relationships, characterized by regular grooming, food sharing, proximity, and coalitionary support that endured across years and seasons and the many changes of a chimpanzee's social world. The quality of these male bonds was particularly strong in two kinds of pairs: males of similar rank,
who perhaps faced fewer competitive pressures with each other and thus had less reason to be adversarial, and males who shared the same mother, meaning they were, in fact, half-brothers. Kinship, it turns out, strengthens social bonds in chimpanzees as it does in humans. Brothers groom each other more frequently and support each other more reliably in confrontations than unrelated males. What does a male chimpanzee friendship actually look like in practice? It looks like two males traveling together through the forest on a morning patrol, moving in easy proximity, occasionally reaching out to touch each other's back as they walk. It looks like one male approaching another who has just obtained a piece of meat, something rare and valuable in the chimp diet, and receiving a portion without any of the tension and competition that characterizes interactions between males who are less close. It looks like one male who, when faced with an aggressive challenge from a higher-ranking individual, finds his friend immediately at his side, a presence that changes the social calculus of the encounter and may determine its outcome.
These coalitions, the mutual backing of allied males in social confrontations, are, as we touched on earlier, the mechanism by which social rank is contested and shifted in chimpanzee communities. An individual male, no matter how physically powerful, is vulnerable to a coalition of 2 or 3 determined, coordinated allies. The history of chimpanzee social groups studied over decades is full of examples of alpha males being displaced not by a single stronger rival, but by pairs or trios of lower-ranking males who had built sufficient alliance with each other to mount a collective challenge. This means that a male chimpanzee's long-term success, its ability to rise in rank, maintain a good position, access resources and mating opportunities, and live a long and relatively secure life, depends enormously on the quality of its social relationships. A socially skilled male, one who has invested consistently in grooming and food sharing and mutual support over years, will often outperform a physically stronger but socially isolated male. In this respect, chimpanzee male social life is a remarkable parallel to human social life. In human societies, too, the most successful individuals are rarely simply the strongest or the largest. They are the ones with the widest and most reliable networks of mutual support, the ones who have invested in relationships over time and can draw on that investment when it is needed. The deep evolutionary roots of this social intelligence, this understanding that relationships are a resource, that the investment of care and attention in others yields dividends, reach all the way back to our shared ancestor with the chimpanzee. The bonds between male chimpanzees are not only politically useful, of course. There is something about them that looks, to careful, honest observation, like genuine affection. Males who have been close companions for years will seek each other's company in moments of stress. When one is injured, the other may stay close by, grooming the wound site, or simply remaining in proximity in a way that seems to provide some comfort. When a close companion dies, there is evidence in some cases of what can only be described as grief, a period of reduced activity, of seeking the usual meeting places and finding them empty, of a behavioral signature that corresponds, in its broad outlines, to what we see in humans who have lost someone they cared about.
This is not sentimentality. This is observation. The forest is darkening now, just slightly. The light through the canopy has taken on the amber quality of late afternoon approaching evening, and the shadows between the trees have grown longer and softer. Around you, the sounds of the forest are shifting. The afternoon birds are quieting, and the evening creatures, the frogs, the crickets, the nightjars, have not yet begun their chorus. This is the liminal time of the forest, the pause between day and night, full of a particular quality of stillness. In the trees above, the chimpanzees are beginning to build their night nests. This is something that many people don't know about chimpanzees. They make a new bed every single night. They do not return to a fixed sleeping place as many mammals do. Instead, each evening, each individual selects a site, usually in the fork of a sturdy tree or a place where several branches converge, and constructs a platform of bent and broken branches lined with softer leaves that forms a shallow bowl just large enough for a single chimpanzee to curl into. The construction takes only a few minutes. The chimp bends branches across each other, hooks them into place, folds leaves into the structure, tests the whole thing with its weight, adjusts, refines, settles. And then it lies down in the nest it has made for itself, curling its body into the natural bowl of the structure, and lets the sounds of the forest surround it as the light fades. Watch them settle for the night. Watch the dark shapes in the canopy grow still against the darkening sky. Their breathing is slow and rhythmic now. Their eyes are closing. And yours can close too, for a little while if you like. There is so much more to tell.
In the world of human cognition, we tend to assume, more or less unconsciously, that our minds are the best on the planet. Not simply the most sophisticated in certain ways, which is demonstrably true, but simply the best, the most capable, the gold standard against which all other animal intelligence should be measured. The chimpanzee, it turns out, has other ideas. The story of chimpanzee memory is one of the most quietly astonishing chapters in all of cognitive science. A story that begins with the question of how an animal moves through the three-dimensional complexity of the forest and ends somewhere that touches, unexpectedly, on questions about the very nature of mind. Let us begin with the long-term memory, the ability to remember individuals, places, and events over extended periods of time. In 2023, a group of researchers conducted a carefully controlled experiment with chimpanzees and bonobos at several research sites. The question they were asking was simple but elegant. Do these apes remember specific individuals they have not seen for a long time? To answer this, the researchers showed each chimpanzee or bonobo a screen displaying two side-by-side images of other apes. One image was of a stranger, an ape the test subject had never met. The other image was of a former group member, an individual the subject had actually known, lived with, and interacted with, but who had not been part of their daily life for months, years, or in some cases, decades. The researchers tracked where the apes looked, which image they attended to, and for how long. They used a technique called eye tracking, which can measure the direction of gaze with extreme precision. The logic was simple. If the apes recognized their old companion, they would probably look at that familiar face differently than at the face of a stranger. And that is exactly what happened. The apes preferentially looked at the faces of individuals they had previously known, even when those individuals had been absent from their lives for years. The most striking individual case in the study involved a bonobo who was shown a photograph of her sister. The two had not seen each other in 26 years. 26 years. More than 2 decades without contact. And yet when the bonobo saw her sister's face on the screen, alongside the face of a stranger she had never met, she looked and kept looking at her sister's face with the kind of sustained attention that speaks of recognition. 26 years of separation, a face not seen in all that time, and memory that held. This result makes chimpanzees and bonobos the holders of the longest long-term social memory ever documented in any non-human animal. And it raises, gently but insistently, a set of questions that are difficult to answer from a purely scientific perspective, but impossible to ignore from a human one. What is it like to look at a face from 26 years ago and recognize it? What, if anything, does that recognition feel like from the inside? What does memory mean to an animal that has it in this degree? We cannot know the answers to these questions. The inner life of another creature is ultimately inaccessible to us. But the fact that the question is worth asking, the fact that the evidence compels us to ask it, is itself significant. It is a reminder that the boundary between human inner experience and the inner experience of our closest relatives is not a clear wall, but a gradient,
a spectrum of capacity and complexity along which we and the chimpanzee occupy positions that are closer than we might once have assumed. Now let us turn to the short-term memory, the working memory, the ability to hold a complex pattern in the mind for a brief period and act on it accurately. This is where the story of chimpanzee cognition takes its most surprising turn. Researchers in Japan at the Primate Research Institute of Kyoto University developed a test of working memory that was both elegant in its design and startling in its results. The test worked like this. On a touchscreen, the numbers 1 through 9 appeared in random positions, scattered across the screen. The test subject had a brief moment to observe their positions, to memorize where each number was placed. Then the numbers disappeared, replaced by plain white squares in the same positions. The subject's task was to touch the squares in the correct numerical order, 1, then 2, then 3, and so on up to 9, even though the numbers themselves were no longer visible. Only the pattern of positions remained, held purely in memory. This is already a demanding task, but the researchers made it more demanding still by varying the time the numbers were visible. In the easiest version, the numbers stayed on screen for 650 milliseconds, a bit over half a second, which is enough time to scan a pattern, but probably not enough to fully memorize it. In the next version, they stayed for only 430 milliseconds. In the most demanding version, the numbers were visible for just 210 milliseconds, roughly a fifth of a second, not even enough time for the eyes to complete a full scan of the screen. The researchers tested 3 groups: adult humans, adult chimpanzees, and juvenile chimpanzees, 5-year-old chimps who had been trained in the basic mechanics of the task. The adult humans performed about as expected, decent at the 650 millisecond version, noticeably worse at 430 milliseconds, and quite poor at the shortest duration. The adult chimpanzees performed similarly to the adult humans. But the juvenile chimpanzees, the 5-year-olds, did something extraordinary. At all 3 time durations, including the briefest 210 millisecond flash, the young chimps performed with high accuracy. Even when the numbers had been visible for only a fifth of a second, a duration so short that adult humans could barely process the fact that anything had appeared on the screen, let alone memorize its spatial arrangement, the young chimpanzees could recall the pattern correctly. They touched the squares in the right order, consistently, reliably, time after time. The reason the juvenile chimps outperformed both adult humans and adult chimps in this task appears to be related to a phenomenon called eidetic memory, sometimes called photographic memory in popular usage. Eidetic memory is the ability to retain a precise, detailed visual image of a scene in the mind for a short time after the scene has disappeared, to hold a mental photograph in effect and read from it rather than from the original visual input. Eidetic memory is something that a small proportion of human children have. Estimates suggest between 2 and 10% of children display some form of it, though it is rare and typically fades as the child grows older. In young chimpanzees, it appears to be the norm rather than the exception. Nearly all young chimps seem to have this capability, and while it does diminish as they mature into adulthood, their visual and spatial memory remains, even in adults, remarkably acute.
Why would evolution favor this extraordinary visual memory in chimpanzees? The most compelling explanation connects back to the forest itself, to the 3-dimensional canopy, to the daily challenge of navigating a complex spatial environment at speed. A chimpanzee moving through the treetops needs to make instantaneous decisions about which branch to reach for next, which route offers the most secure passage, where the fruiting tree is relative to its current position. The ability to perceive a complex spatial scene in an instant and hold it accurately in working memory, to take, in essence, a mental snapshot, would be an enormous advantage in this environment. Scientists believe that this memory skill might also be valuable for quickly identifying threats in a complex visual field, the sudden appearance of a predator partially concealed by foliage, the unfamiliar silhouette of a rival group member in the canopy above. In an environment where decisions must be made in fractions of a second, a mind that can process and retain visual information with extreme speed and accuracy is a mind well adapted to survival. Human brains, by contrast, have invested in different cognitive real estate. Language, abstract reasoning, long-term planning across extended time horizons. These are the domains in which human cognition has been most dramatically amplified. The extraordinary visual spatial working memory of the young chimpanzee has been traded, in our lineage, for the extraordinary linguistic and abstract cognitive capacities that make human civilization possible. Two paths from one ancestor, each optimized for its own world. Lie still in the warmth of this thought. Let your breathing be deep and even. The forest around you is fully dark now, not the harsh darkness of a room with the lights out, but the living darkness of a forest at night, where the absence of direct light only reveals 1,000 softer luminosities. The pale shimmer of a moonlit branch, the faint glow of bioluminescent fungi on a fallen log, the moving light of fireflies in the understory. The chimpanzees are settled in their nests now. You can hear, if you listen carefully, the soft sound of their breathing, slow, regular, the deep rhythm of animals in easy sleep. The story of chimpanzee intelligence does not end with memory. Memory is, in a sense, the foundation, the substrate on which other cognitive capacities are built. But what chimpanzees do with their memory, how they apply it in the service of reasoning, strategy, and social navigation is equally remarkable. In 2014, a research team designed an experiment that drew on one of the most elegant frameworks in all of economics and psychology: game theory. Game theory is the mathematical study of strategic interaction, of how rational agents make decisions when the outcome of their choices depends on the choices of others. It has been applied to nuclear deterrence, to market competition, to voting behavior, to evolutionary biology, and in 2014, it was applied to chimpanzees. The game was simple in structure and fascinating in implication. Two players sat in front of side-by-side touchscreen panels, separated so that neither could see the other's choices until after both had selected. Each player had two options. Let us call them left and right. One player was designated the matcher. They wanted their selection to match the other players. The other was the non-matcher. They wanted their selections to be different. Neither player could see what the other had chosen until after both made their selection, at which point the result was briefly revealed. In a perfectly rational world where both players make optimal strategic choices, game theory can predict exactly what the equilibrium state of this game looks like, the precise probability with which each player should choose left or right, such that neither can improve their outcome by changing their strategy. This is called the Nash equilibrium, and computing it requires integrating information about the other player's past choices and adjusting one's own strategy in response. When pairs of adult humans played this game, their choices drifted far from the predicted equilibrium. Human players showed patterns of bias and predictability. They favored one option slightly over the other, or developed strategies that the opponent could exploit by tracking their patterns. Their games were suboptimal. When pairs of chimpanzees played the same game, the results were dramatically different. The chimp pairs played at strategies that were strikingly close to the game-theoretic equilibrium. They appeared to track their opponent's choice history, update their own strategy in response, and maintain a near-optimal random distribution of choices that resisted exploitation. Their games were, by the quantitative measure of game theory, better than the humans. This is a remarkable finding. It suggests that chimpanzees possess, in the domain of strategic social interaction, a form of applied intelligence that is not simply comparable to human intelligence, it surpasses it in this particular domain. Why might this be?
The answer, again, connects to the social world of the chimpanzee. A chimpanzee lives in a community where social competition is constant, where the stakes of social interaction are high, access to food, to mates, to safety, and where the ability to track the behavior of other individuals, predict their next move, and adjust one's own behavior accordingly is literally a matter of survival and reproductive success. The strategic intelligence tested by the game theory experiment is not an abstract academic skill. It is the cognitive engine that runs chimpanzee social and political life. Consider what a chimpanzee must do to navigate its social world effectively. It must remember the recent actions of dozens of individuals. It must update its model of each individual's current social state, their mood, their alliances, their recent gains and losses. It must anticipate how a given action of its own will be perceived and responded to by multiple other individuals simultaneously. It must weigh short-term costs and benefits against long-term relationship consequences. It must, in effect, run a continuous real-time simulation of the social world around it and take actions that optimize its position within that simulation. This is not simple. It is not instinctive in the sense of being a fixed, pre-programmed response to a specific trigger. It is flexible, learned, context-sensitive, strategic. It is, in the fullest sense of the word, intelligent. Frans de Waal, one of the world's leading primatologists and a researcher who has spent decades studying chimpanzees and other great apes, has used the word Machiavellian to describe chimpanzee social intelligence, a term that captures the strategic, politically aware quality of their behavior. But de Waal is also careful to emphasize the other side of this intelligence, the empathy, the reconciliation, the care. Because the same cognitive architecture that supports strategic maneuvering in chimpanzee social life also supports something else entirely: the ability to understand what another individual is experiencing and to respond to that experience with something that deserves to be called empathy.
When a fight occurs between two chimpanzees, which in a community with real hierarchical tensions is not uncommon, something usually happens afterward that is easy to overlook but deeply significant. The losing animal, or sometimes both animals, will typically be approached by a third party, often an uninvolved bystander, who gently reaches out and touches the distressed individual or grooms it quietly for a few minutes. This behavior, called consolation by researchers, reduces the stress hormones and calms the heart rate of the recipient. It is not a strategic behavior. It does not benefit the consoler in any obvious material way. It is simply one chimpanzee recognizing that another is upset and responding to that recognition with comfort. Consolation has been documented in chimpanzees, bonobos, gorillas, elephants, wolves, and, perhaps unsurprisingly, humans. In chimpanzees specifically, it has been observed consistently across multiple study sites and appears to be a genuine, reliable feature of their social repertoire. It is, in the most precise scientific language available, an empathic response. De Waal has argued that the roots of human morality, our capacity for fairness, for empathy, for care, are not unique inventions of our species, but evolved features of a deep primate heritage that we share with our closest relatives. The chimp who approaches a distressed companion and offers comfort is not practicing a human virtue by accident. It is doing what evolved social mammals do, responding to the emotional signals of others in a way that maintains the social bonds on which survival depends. This is a thought worth holding in the warmth of this forest night. We did not invent kindness from scratch. We inherited it from an ancestor whose descendants also became the chimpanzee, an animal that comforts its companions, that grieves its lost friends, that remembers a sister's face for 26 years, that forms bonds of loyalty and affection that last for decades. Let your breathing be slow and full. The darkness of the forest is complete now and beautiful. The insects have begun their gentle rhythmic chorus, the steady pulsing of crickets, the occasional deep note of a frog near the river, the soft sound of leaves moving in a night breeze.
The chimpanzees in their nests are still. Their breathing is the slow, regular breathing of deep sleep. And yours can be too. In the landscape of cognitive science, there is a question that has occupied researchers for decades. Do animals other than humans have a theory of mind? This technical-sounding phrase refers to a profound cognitive capacity, the ability to understand that other individuals have their own mental states, their own beliefs, their own knowledge, their own perspective on the world, which may be different from yours. It is the capacity that underlies empathy, deception, teaching, and complex social coordination. It is the capacity that allows you, right now, to imagine what it might be like to be a chimpanzee in a forest at night, to step mentally outside your own perspective and inhabit another. For a long time, scientists believed that this capacity was uniquely human, that while other animals could learn to predict behavior based on past observation, none of them could truly understand that other individuals have inner mental states distinct from their own. Chimpanzees have been at the center of the debate that has slowly, carefully, piece by piece dismantled this assumption. The key experiments involve situations where what a chimpanzee knows about a social situation is different from what another individual knows, and the question is whether the chimpanzee understands and acts on this difference. In one especially elegant experimental series, researchers created situations where a subordinate chimpanzee and a dominant one were both present, and food was hidden in locations that one or both of them could see. The logic was this: a dominant animal will nearly always outcompete a subordinate for food if they both know where the food is. So, if a subordinate chimp understands that the dominant one does not know about a particular piece of food, if it understands that the dominant's knowledge differs from its own, it should preferentially go for that hidden piece rather than competing directly for the visible one. And that is exactly what the subordinate chimps did. They consistently sought out food that was visible only to themselves, demonstrating a clear implicit understanding of what the dominant animal could and could not see. They were not just responding to the visual scene, they were modeling the mental state of another individual, specifically what that individual knew. Further experiments tested an even more demanding version of this capacity, understanding that another individual can hold a false belief. This is the classic test of full theory of mind. A false belief occurs when an individual believes something that is not currently true, when their internal model of the world does not match reality because something has changed without their knowledge. In one version of this test, chimpanzees watched a video sequence. In the video, a person placed an object in a box and then left the room. While the person was gone, another individual moved the object to a different box. Then the first person returned. The question the researchers asked was, where do the chimpanzees look when the first person returns? Do they look at the place where the object actually is, or at the place where the first person left it and where she would mistakenly believe it still to be? The chimpanzees, measured by careful eye tracking, looked to the place where the first person had left the object. They anticipated that she would look there based on her now outdated knowledge. They understood, at least in this basic form, that another individual can have beliefs that differ from reality. This test, the false belief test, is considered by cognitive scientists to be the gold standard for theory of mind. It requires not just tracking behavior, but modeling the internal states of another mind. And while chimpanzees do not show this capacity as robustly or as consistently as adult humans, they show it enough to make clear that the cognitive foundation of theory of mind is not a human invention. It is a shared primate inheritance. The implications of this ripple outward in directions that are both scientifically profound and, in the quiet of a forest night, quietly moving. A chimpanzee that can model another individual's beliefs, that can understand even approximately what another mind knows and doesn't know, is an animal for whom other minds are real. Other individuals are not just moving objects that produce predictable outputs. They are subjects with inner lives, with perspectives, with states that matter. And if other minds are real to a chimpanzee, if the chimpanzee inhabits a social world in which other individuals are understood as having inner experience, then the bonds between them, the friendships and the loyalties and the acts of comfort, carry a weight that goes beyond mere behavioral exchange. They mean something. Not in the linguistic, philosophically articulated way that things mean something to humans, but in some older, more immediate, more bodily sense of meaning. The sense in which the warmth of a companion resting close by means something, in which the familiar face of a sister means something after 26 years of absence, in which the presence of a trusted ally means something in the moment when it is most needed. Breathe this in slowly. Let it settle into you. In the canopy above, a chimpanzee stirs briefly in its nest, shifts its position, and settles again. Its sleeping companion adjusts in response, moving slightly closer, its body curling toward the other's warmth. Two minds at rest, together in the living darkness of the forest.
A chimpanzee does not have language in the way that you do. It cannot arrange words into sentences that express complex, abstract propositions. It cannot write its memories down or pass them to the next generation in the form of books or stories. The particular form of language that humans use, the hierarchical, recursive, infinitely generative grammar that allows us to say things no one has ever said before, is not part of a chimpanzee's natural repertoire. But a chimpanzee is very far from silent. Its communicative world is rich, nuanced, and in certain respects more sophisticated than we tend to give it credit for. Researchers studying chimpanzee communication in the wild have cataloged 66 distinct gestures used by these animals, with 19 core communicative meanings. These gestures are not stereotyped, automatic signals in the way that a dog wagging its tail is automatic. They are intentional, produced when there is an audience to receive them, modified when the first attempt does not produce the desired response, and used flexibly across different social contexts. A chimpanzee wanting to be groomed will approach a companion and present a particular body surface, a shoulder, the top of the head, the belly, and hold the position with a quality of patient expectation that is unmistakable. If the other chimp doesn't respond, the first will often try again, perhaps more explicitly, tapping the body part or turning to face the potential groomer. If the invitation is accepted, the first chimp will relax into the grooming with the ease of one whose request has been understood. Gestures are used to coordinate movement. A chimp wishing to travel will glance pointedly in the direction of travel, sometimes combining this with a particular posture or movement that invites the other to follow. Gestures are used in play, the open-mouthed, loose-limbed play face that signals, clearly across the species boundary as well as within it, this is not a real fight, this is fun. Gestures are used to request food sharing, to signal appeasement after a conflict, to invite physical contact, to threaten, to reassure. Beyond gestures, chimpanzees have a repertoire of vocalizations that is both extensive and contextually meaningful. The most famous is the pant hoot, a long, complex call that begins with a series of soft hoots, builds in volume and pitch through increasingly excited panting calls, and culminates in a loud, rolling scream that can carry through the forest for more than a mile. Pant hoots are individually distinctive. Every chimpanzee has its own signature version of the call, and other chimps can recognize the caller from the sound alone. Pant hoots are used for a range of purposes: announcing location, greeting other group members after a separation, expressing excitement about food, coordinating movement within and between groups. When a chimpanzee calls out from the canopy and another answers from a quarter-mile away, the two calls weaving together across the distance of the forest, there is a quality of connection in those sounds that crosses the language barrier entirely. You do not need to speak chimpanzee to hear, in that exchange, something that functions very much like calling out to a friend and hearing them call back. Then there is the question of language learning. Beginning in the 1960s and continuing for decades, researchers attempted to teach various apes to communicate using human-derived symbol systems. The most famous of these projects involved a chimpanzee named Washoe, who was raised by researchers Alan and Beatrix Gardner and taught American Sign Language from infancy. By the end of her language training, Washoe had acquired approximately 245 signs and could use them in combinations to express requests, describe situations, and communicate with her human companions. Washoe was not alone. Other chimpanzees taught similar systems. Tatu, Lulis, Moya, among others, acquired vocabularies of between 70 and well over 200 signs. And crucially, Washoe was observed teaching signs to her infant son, Lulis, the first documented case of a non-human animal teaching human-derived symbolic communication to its offspring. What these apes did not do, and this is important to acknowledge clearly, is demonstrate the kind of recursive, open-ended grammar that characterizes human language. They could combine signs into phrases. Washoe famously produced waterbird when first seeing a swan, a novel combination that seems to express a compound concept. But the combination rules they used were simpler and more constrained than human syntax. They were communicating meaningfully and intentionally with symbols, but they were not speaking in the full linguistic sense of the word. What they were doing, though, is remarkable enough on its own terms. Using learned symbolic representations, remembering them across years, applying them flexibly in new situations, and in at least one case, passing them on to the next generation. This is a form of cultural transmission, the transmission of learned information from one generation to the next that goes well beyond anything we once thought possible in a non-human animal. The forest has grown deeply quiet around you. The cricket chorus has settled into its steady, low pulsing. A bat crosses the opening between the canopy and the sky, its wing beats a brief, soft flutter. The air is cooler now, just slightly, the way forest air cools in the hours after midnight. Let your breathing match the rhythm of the forest, slow, easy, generous. In 1960, a young woman named Jane Goodall was sitting in a forest clearing in what is now Tanzania when she witnessed something that would change the course of science. She watched a chimpanzee, a large male she had come to know by the name David Graybeard, pick up a long grass stem, strip the leaves from it with careful fingers, and carry it toward a termite mound. At the mound, David Graybeard inserted the modified stem into a tunnel entrance and held it there for a moment. When he withdrew it, the stem was covered with termites, which he carefully ate. Then he prepared another stem and did it again. Goodall had just witnessed, for the first time in documented history, a non-human animal making a tool. Not simply using an object as a prop, but modifying it, deliberately changing its form to make it more effective for a specific purpose. She had witnessed fabrication, the intentional shaping of a material toward a goal. When Goodall reported this observation to her mentor, the renowned paleontologist Louis Leakey, his response has become famous. Now we must redefine tool, redefine man, or accept chimpanzees as humans, he said. The discovery forced a fundamental revision of the boundary that had long been drawn between human cognition and that of other animals. Since Goodall's discovery, the range of tool use documented in wild chimpanzees has grown substantially. In different populations across Africa, chimps have been observed using stone hammers and stone anvils to crack open hard nuts, a behavior so complex that it requires matching the appropriate hammer weight to the nut type, positioning the nut correctly on the anvil, and calibrating the force of the strike.
Juvenile chimpanzees spend years learning this skill by watching their mothers and do not achieve adult-level competence until they are around 10 years old. Fashioning pointed sticks to use as spears for hunting bush babies, small nocturnal primates that sleep in hollow trees. The chimpanzee breaks a branch from a tree, strips it of bark, and sharpens one end by biting it to a point. It then thrusts this improvised spear into tree cavities where bush babies shelter. This behavior, documented in Senegal, involves planning, tool manufacture, and targeted application, all in the service of a hunting technique rather than a gathering one.
Making absorbent leaf sponges to retrieve water from tight spaces that their lips cannot reach. Rolling leaves into a compressed bundle, dipping it in water and squeezing it into their mouth. The creation of this simple but effective water collection tool requires understanding both the problem and the solution, and choosing to modify an available material to bridge the gap between them. Using large leaves as rain covers, holding a leaf above their head while walking through a shower, a behavior that looks, to human eyes, startlingly familiar. What all of these behaviors share is not just the physical dexterity required to make and use tools. It is the underlying cognitive architecture, the ability to represent a goal state, to recognize that the current situation does not match that goal, to identify a material in the environment that could serve as a bridge between the two, and to take deliberate, multi-step action to transform that material and deploy it effectively. This is planning. This is the understanding of cause and effect. This is the ability to model a future state and work backward from it to determine what needs to happen now. And, crucially, it is learned and transmitted culturally. Different chimpanzee populations have different tool cultures. The chimps of one region crack nuts, while those of another, in apparently identical habitat with identical access to the same nut species, do not. The tool knowledge of one generation is passed to the next through observation and practice, not through genes. It is, in the precise biological sense of the word, culture. Jane Goodall, reflecting on 60 years of observing chimpanzees, has said that one of the most important things she came to understand is that chimpanzees are individuals, not just members of a species, but personalities. Each chimp she came to know had its own distinct character, timid or bold, aggressive or gentle, playful or serious, curious or cautious. The differences between individuals were as real and as significant as the differences between any group of humans you might assemble in a room. This observation, which seems simple when stated plainly, was itself a kind of scientific revolution. It moved the study of chimpanzees from the abstract, behavior patterns, statistical frequencies, population-level dynamics, to the particular. This animal, this life, this individual with its own history, its own relationships, its own way of moving through the world. And, in the particular, something ineffable becomes visible.
At the heart of every chimpanzee's life, shaping everything from the earliest days to the latest, is a single relationship that precedes all others: the bond with the mother. A chimpanzee birth is a quiet, private event. Females typically give birth alone or with only a very close companion nearby, in a sheltered spot in the forest, usually at night. The infant arrives into the world small and relatively helpless, unable to hold its head up independently, unable to coordinate its limbs, relying entirely on its mother for warmth, nourishment, and the sense of security that is, for any young primate, as essential as food. The newborn chimpanzee clings to its mother almost continuously, first to her belly, then, as it grows stronger and more coordinated, to her back, where it can look out at the world over her shoulder as she travels and feeds. This physical closeness is not merely practical. It is, for the infant, the entire world. The warmth of the mother's body, the rhythm of her breathing, the vibrations of her voice, the familiar scent of her fur, the slow rocking of her movement through the trees. A mother chimpanzee nurses her infant for 3 to 5 years. During this time, the infant's gradual process of independence is carefully negotiated. The mother sets the pace of this development, allowing the infant to venture short distances, to interact briefly with other members of the community, to explore the physical environment from the safety of her proximity. When the infant is frightened or hurt or overwhelmed by the complexity of the social world, it returns to its mother. When it is ready to try something new, it ventures out again. The rhythm of exploration and return, of confidence and comfort, plays out in the daily life of every young chimpanzee. This process of learning is comprehensive. The young chimpanzee watches everything its mother does with an intensity that is remarkable to observe. It watches her choose which fruits are ripe and which are not, building a mental library of the hundreds of plant species in its forest home. It watches her navigate social interactions, observing who she approaches and who she avoids, how she responds to threats and opportunities. It watches, above all, her tool use, following her fingers as she strips a grass stem or positions a nut on an anvil, sometimes trying tentatively to imitate what it has seen, rarely succeeding at first, but gradually refining its technique over years of patient practice. The relationship between a chimpanzee mother and her grown offspring does not end with weaning. Adult chimpanzees maintain relationships with their mothers into old age. A young male who has risen in the hierarchy may return to groom his aged mother. A female who has given birth for the first time may rely on her mother's proximity and guidance during the uncertain early weeks of infant care. The mother-child bond in chimpanzees is, along with male long-term friendships, one of the most durable and stable social relationships in their complex community life. Jane Goodall wrote movingly about the maternal relationships she observed over decades at Gombe, about mothers whose personality and social status shaped the lives of their offspring for years after independence, about the grief that young chimps showed when they lost their mothers, about the care and patience with which good mothers guided their young through the complexity of forest life. She described one mother in particular, Flo, as an exceptional parent, playful, patient, attentive, generous, and observed that Flo's children were, as adults, among the most confident and socially successful individuals in the community. The quality of early maternal care, Goodall came to believe, shaped the character of the adult animal in ways that were deep and lasting and real. This is not so very different from what developmental psychologists tell us about human children. The warmth of a mother's presence, the security of a reliable bond, the freedom to explore from a safe base. These are not species-specific luxuries, they are primate necessities, the conditions under which a young mind can grow most fully into its own potential. Let that thought settle gently.
The ancient forests where chimpanzees live are among the most biodiverse places on the surface of this planet. A single hectare of African tropical rainforest, roughly the size of 2 football fields, may contain hundreds of species of trees, thousands of species of insects, dozens of species of birds and mammals and reptiles, and an almost incomprehensible web of ecological relationships connecting them all. These forests are also among the most threatened. Over the course of the 20th century and into the 21st, African forests have retreated dramatically before the advance of human activities, logging, agricultural expansion, mining, road construction, the growth of human settlements. By some estimates, more than 80% of the forests that once covered West Africa have already been cleared or significantly degraded. What remains is fragmented, broken into patches, islands of old forest separated by cleared land, limiting the movement of animals, interrupting gene flow between populations, making entire communities vulnerable to local extinction. For chimpanzees, who depend on large, continuous forest areas for their complex social and ecological needs, this fragmentation is devastating. A community needs territory, enough trees to feed the community through all seasons, enough space to maintain the social dynamics that their fission-fusion society requires, enough separation from human settlement to avoid the conflicts that arise when chimps and farmers share the same landscape. There are, as mentioned earlier, between 170,000 and 300,000 chimpanzees left in the wild. That range of uncertainty is itself telling, a reminder that these animals live in places and in ways that make them difficult to count, and that the precision required to protect them effectively is often difficult to achieve. What is clear is that the number has been declining, and that without significant and sustained effort, it will continue to decline. But here is something equally important. The efforts to protect chimpanzees are real, and in many places they are working. Across the chimpanzees range in Africa, national parks and wildlife reserves protect significant areas of critical habitat. Gombe Stream National Park in Tanzania, where Jane Goodall began her research more than 60 years ago, remains a stronghold for one of the best-studied chimpanzee communities in the world. Tai National Park in Côte d'Ivoire, Kibale National Park in Uganda, Bosu in Guinea, the forests of Cameroon and the Democratic Republic of Congo. These places are the anchors of chimpanzee conservation, the places where the animals and the science and the protection all come together. These are not the behaviors of a creature whose life is without value. They are the behaviors of a creature whose life is full of it. The roots of this recognition stretch back to everything we have talked about tonight. The memory that holds a sister's face for 26 years, the friendship that endures for a decade, the mother who carries her infant on her back through the canopy and patiently teaches it to crack a nut, the long-fingered hand that reaches out in the darkness to comfort a frightened companion. These are not the behaviors of a creature whose life is without value. They are the behaviors of a creature whose life is full of it. Consider for a moment the people who dedicate their professional lives, and in many cases their entire personal lives, to the protection of chimpanzees and their habitat. The field researchers who spend years in remote forests, sometimes months at a time without access to the conveniences of modern life, slowly habituating chimp communities to their presence so that meaningful observation can take place. The wildlife rangers who patrol the boundaries of protected areas in conditions of real hardship, confiscating snares and documenting evidence of poaching. The educators who drive on rough roads to remote schools to teach children who have never seen a scientific journal about the extraordinary animals living in the forests visible from their classroom windows. The sanctuary workers who bottle feed orphaned chimpanzees in the middle of the night, who build trust week by week with traumatized animals that have never known a secure social world, who work patiently toward the moment when an once isolated chimp can be introduced into a social group and discover, for the first time, the deep comfort of living among its own kind. These people are not acting from abstraction. They are acting from knowledge, and knowledge has become care, and care has become commitment. This is the same chain that Jane Goodall described: understand, care, help. And it is playing out in real lives, in real forests, in the real ongoing work of people whose names most of us will never know, but whose efforts hold the line between extinction and survival for an extraordinary species. What each of us can contribute to this chain may look different. For some, it is direct action, volunteering, donating, advocating for policy change. For others, it is something quieter: choosing to know, choosing to care, choosing to hold in our minds and hearts the reality of these animals and their world, and to let that reality inform how we think about our relationship to the natural systems that sustain all life, including ours. In the Thai forest of Côte d'Ivoire, chimpanzee communities have been studied for over 40 years. These are some of the most intensively monitored wild animals on Earth, and what the data shows is both sobering and encouraging. Sobering because the populations in and around the forest have declined significantly due to disease and habitat pressure. Encouraging
because the protected core of the forest and the commitment of the researchers and rangers who work there has maintained a viable community of animals that continues to be studied, protected, and, in many years, to grow in numbers. In Uganda's Kibale National Park, a long-term research project that has been running since the 1980s has produced some of the most detailed records of wild chimpanzee life available to science. The chimps of Kibale have become, over decades of habituation, almost entirely comfortable with human observers, moving through their daily routines with researchers following quietly behind, creating a data set that spans generations of individual chimps and captures, in extraordinary detail, the birth and growth and social lives and eventual deaths of animals who have, by now, been known to science for the entirety of their lives. These long-term studies are irreplaceable. Chimpanzees live for 40 to 50 years in the wild, and many of the most important questions about their social lives, how rank is achieved and maintained over a lifetime, how early maternal relationships shape adult behavior, how community composition changes across generations, can only be answered through observations that span decades. The researchers who commit to these long-term projects are, in a sense, making a gift to the future, building a record that will inform conservation decisions and scientific understanding for generations to come. The forest has been a gift to all of life for hundreds of millions of years. The trees that shade the chimpanzees tonight have been doing this work, breathing, growing, sheltering, feeding, for far longer than our species has existed. The river that runs through this forest has carried water from the highland watershed to the lowland plains through all the many changes of climate and landscape that have shaped this continent. The soil beneath the roots of these ancient trees holds the accumulated organic matter of countless generations of forest life. This is what we are working to protect. Not just the chimpanzees, though they are in themselves reason enough, but the whole irreducibly complex, gloriously alive fabric of the tropical forest that holds them. Jane Goodall, who has devoted her life to understanding and protecting these animals, has spoken with both sorrow and hope about their future. The sorrow is for what has been lost, the forests cleared, the populations reduced, the individuals caught in traps or killed for bushmeat or taken as infants for the pet trade. The hope is for what is being built, the networks of people, from international scientists to local forest rangers to school children in villages at the forest edge, who understand what chimpanzees are and who are working in their different ways to ensure that the ancient forests still hold these animals 100 years from now. Only if we understand, Goodall has said, will we care. Only if we care will we help. Only if we help shall all be saved. The forest is quiet and dark. The river is the only sound, the steady, patient voice of water over stones, flowing as it has flowed for longer than any human memory, longer than any chimpanzee's memory, longer than almost any living thing can comprehend. The water does not worry about the future. It simply flows, persistent, present, alive. Breathe with the forest now. Breathe with the river. The night is deep. In the canopy above you, the chimpanzees are sleeping the deep sleep of creatures who have spent their day fully, who have traveled and fed and groomed and played and navigated the extraordinary complexity of their social world with all of their considerable intelligence and attention. Their nests hold them gently. Their bodies are warm and relaxed in the cool night air. Around them, the forest continues its quiet, ceaseless work. The trees breathe, taking in the carbon dioxide of the night air, offering back oxygen in the invisible chemistry of their leaves. The fungi at their roots continue the slow, patient process of decomposition and transformation,
breaking down the fallen wood and leaf litter of the forest floor into the rich, dark soil that will feed the next generation of trees. The insects continue their chorus. The river continues its passage over stones. All of it connected, all of it continuous, all of it part of a single, vast, living system that began on this planet nearly 4 billion years ago and has been running without a pause ever since. Think about that continuity for a moment, as your own breathing deepens and slows. 4 billion years of life on this planet. 4 billion years during which the chemistry of cells, the coupling of organisms and reproduction, the slow accumulation of variation and selection, the great engine of evolution, has been running. In that enormous span of time, countless lineages have arisen and dissolved. Creatures have flourished in forms we can only imagine from their fossilized bones, or not even that, forms that left no trace at all, whose brief flowering in the history of life is entirely invisible to us now. And from that inconceivably vast and patient process, this emerged: a chimpanzee in a forest nest and a human being listening in the dark. Two minds, shaped from the same ancient clay, differentiated by 6 to 7 million years of separate experience, but still sharing the deep architecture of feeling and memory and social connection that our common ancestor carried in its own body, in its own forest, millions of years before either of us came to be.
You are part of that system too. Every cell in your body carries, in its nucleus, a record of the history of life on Earth, the accumulated DNA of billions of years of evolution, of all the creatures that preceded you and whose survival made your existence possible. In that DNA, woven in like a thread through a tapestry, is the evidence of your kinship with the chimpanzee. The 98% shared inheritance, the common ancestor, the two paths that diverged in an ancient forest and eventually led to this: a human being, resting in the darkness, aware of the forest and the animals and the immense, generous continuity of life. What does it mean, really, to be that closely related to another kind of mind? It means that when you see a chimpanzee mother carrying her infant with care, some ancient part of you recognizes what you are seeing. It means that when you watch two chimps grooming each other in the afternoon light, the feeling that rises in you is not just aesthetic, it is recognition, something closer to family feeling than we usually allow ourselves to admit. It means that the grief of a chimpanzee who has lost a companion is not a metaphor for grief. It is grief, from the same evolutionary source, running in a slightly different channel. We are kin. Strange kin, separated by millions of years and the enormous cultural distance that human intelligence has created. But kin. There is a word in Japanese, mono no aware, that translates roughly as the bittersweet awareness of impermanence, the poignant beauty of things that will not last forever. It is the feeling you get watching autumn leaves fall, or watching a sunset, or watching a child asleep who will not always be so small. It is a feeling that requires a consciousness capable of holding simultaneously the beauty of the present moment and the knowledge of its transience. When we look at the chimpanzees in their forest, when we really look with the full knowledge of what they are and what they face, we feel something like this. The beauty of those ancient trees, those complex minds, those durable bonds of friendship and family, set against the knowledge of the pressures that bear on them. The poignancy is real. It is not sentimental, it is honest. And honesty in the face of what is genuinely beautiful and genuinely at risk is one of the most important things we can offer. But poignancy does not have to become despair. It can become commitment. The quiet, durable commitment of someone who has really seen something and cannot unsee it. The commitment to know and to care, and in whatever way is possible, to help. In that commitment, something ancient is alive. the same capacity for loyalty that binds a male chimpanzee to his companion for a decade, the same impulse to protect that drives a mother to keep her infant close through the long years of its growing, the same recognition that runs between two chimpanzees who have known each other for 26 years and still know each other's faces. We did not invent these things, we inherited them. And in that inheritance, there is something that feels, if you let yourself feel it fully in the quiet of this forest night, like a responsibility and like a gift. The responsibility to protect the forests and the animals that share our evolutionary heritage, to work in whatever ways are available to each of us toward a world in which the ancient chimpanzee calls still echo through the canopy of Gombe and Tai and Kibale, in which the next generation and the one after that and the one after that can still walk into a forest and look up into the green light of the canopy and see a dark shape reaching between branches, turning its quiet, intelligent face downward and recognizing in the same ancient wordless way something familiar. The gift is simply this: knowing. Knowing that you are not alone in the universe of minds, that consciousness and memory and friendship and grief are not human inventions, but human expressions of something older and wider and more generous than any single species. Knowing that the empathy you feel, the love you carry, the bonds that hold your life together, these are not unique to you, but are part of a great inheritance, shared with creatures who carry them in different forms, in different forests, in the same night that covers all of us. The forest around you is completely still now. The insects have quieted to a low, continuous murmur. The river is the only real sound, the patient, unbroken voice of water over stone, always moving, never hurrying, never stopping. Above you, the canopy makes a dark geometry against the faintly luminous sky, and somewhere in its heights, the chimpanzees are breathing in the slow, deep rhythm of undisturbed sleep. Let your own breath find that rhythm. In, slowly, fully. Out, completely, without holding anything. In again. Feel the air fill your lungs, this air that the trees have made, that carries in it the chemical generosity of 1,000,000 forest leaves. You are breathing the breath of the forest. Out. And as you breathe out, let whatever you have been holding, whatever tension, whatever worry, whatever the day has left in your body, let it go with the breath, offered back to the night, dissolved into the air, released. You have traveled far tonight. You have walked, in the imagination, into one of the oldest and most extraordinary living systems on this planet. You have seen the body of the chimpanzee, those long, curved fingers, those grasping feet, that compact and powerful frame built for the vertical world of the canopy. You have understood the muscle and the bone and the extraordinary physical capability that this body carries. You have watched the chimpanzee's mind at work, storing the pattern of numbers in a fraction of a second, recognizing a sister's face after 26 years, reading the knowledge and intentions of a companion and responding with empathy and care. You have glimpsed the architecture of a mind that is not human, but is, in its deepest structure, made of the same stuff as yours. You have sat in the warmth of their social world, the grooming, the friendships, the alliances, the long bonds of loyalty and care that sustain individual chimps through the complex, competitive, sometimes difficult world of the forest community. You have understood that love, in its oldest and most fundamental forms, was here long before language, long before civilization, long before any human being looked up at the stars and began to wonder. And now, as the night deepens and the forest holds all of this in its dark, patient embrace, let yourself simply rest in the knowledge that you are part of something enormous, something alive and ancient and connected, something that will persist, if we care for it, far beyond any individual life. Let this knowledge settle into you now, slowly and completely. Let your breath be the breath of the forest. Let your mind be as still and as alive as the river. Let the distance between you and the ancient trees and the sleeping chimpanzees collapse for just this moment into the simple, fundamental fact of being alive, together, on this one beautiful planet. The forest holds you. You are safe. You are connected. You are home. Sleep now.
Let your thoughts grow softer, like the light through the canopy at dawn, diffuse and gentle, and without sharp edges. Let the image of the forest be the last thing you carry, the green and the gold, the dark shapes in the branches, the river, the soil, the ancient, patient, breathing trees. Sleep. In the forest, the chimpanzees dream whatever chimpanzees dream. Perhaps the roots between fruiting trees, perhaps the face of a companion, perhaps nothing we could name, only the warm, undifferentiated contentment of a body that is held and a mind that is at rest. May your own rest be as deep. May your own dreams be as green. Sleep. Sleep in the deep and living dark of the oldest forest on Earth.